Okay, so for the first two radicals, you end up with 4x squared root 2x. And then you look at your third radical, and you're like, it's not a like term. But is your third radical simplified? No. So simplify it. 8 is 4 and 2, and x cubed. Right, the power is small, so I'm just picking out my perfect squares. And so we end up with minus 2 x squared. Notice the x is already here, so when one of them comes out, that power goes up. Left with 2x. And now I have a like term. X squared root 2x, x squared root 2x, which means this simplifies to 2, 4 minus 2. Keep the like term exactly the same. Exactly the same. Yeah. Okay, so this x right here, when I pulled out this perfect square, x times x. Okay, let's do one other short example here. Root 6 plus root 2 all over root 6 minus root 3. Okay, right, I see add, subtract, and divide. So we have 3 operations here. PEMDAS still applies. Can you add anything in the numerator? Root 6, root 2. No, they're not the same. So we can't add them. When I say the same, remember, radicals are exponents. They both have a 1/2 power, but the bases 6 and 2 are different. Okay? Can I subtract? No. That leaves me with divide. What we learned yesterday is that division, you can't box an answer with a radical in the denominator. Yeah.
Why can't you just use the conjugate?
We can. So how do I get my radical out of the denominator? Now it's still got to be equal to 1. Okay? This is called rationalize. How do I rationalize? I multiply by 1, but you have to strategically pick the quantity.
So wait, would it be radical?
It's going to be radical 6 plus root 3. I need the quantities in the denominators to turn into a real number. Conjugates multiplied result in a rational number. That's why it's called rationalize. Rationalize. Turn it into a rational number. So when you multiply those conjugates, you get a rational denominator. Okay? Now this does have to be 1, so I'm going to copy the same quantity here. I'm going to FOIL. It's multiply. FOIL. First, outer, inner, last. Okay, first, root 6 times root 6. Outer, root 6 times root 3. Root 2 times root 6. I wouldn't usually write it out like this, but I want to see that you're just multiplying. Root 2 times root 3. Now that is just the numerator right now. Can you combine anything? Well, I'm pretty sure multiplying radicals says that I can put the 6 and the 3 together, which is root 18. But root 18
Wait, how do you get 6 whole?
is 9 and 2. I'll answer it in 1 second. 9 and 2. So this is really 3 root 2. Okay, root 2 times root 6 is root 12. Would I probably skip straight to root 18? Yeah. I might even skip straight to 3 root 2 if I had some scratch paper.
Never mind it.
Okay, so yes, 2 root 3. Okay, root 6. All right, there's your numerator. Can you add any of those things? No, they are not like terms. Okay, now you have to do your denominator. All right, FOIL your denominator. See what you get. Okay, so here we go. I'm going to redo it because I ran out of space. So 6 plus root 18 is 9 and 2, so 3 root 2. Inner, root 12, so 2 roots 3, plus root 6. Okay, here we go. Denominator, first, 6. Outer, root 18. Outer is root 18, but inner is minus root 18. 0. Right? Conjugates, the radicals should disappear. Last, minus 3. Last. First, outer, inner, last. Here's your outer and your inner. They cancel out. Okay, final answer. Over 3. Now the question is that done? Can anything be added? No. Can anything be reduced?
Wait, how come you don't do square root of 6 times square root of...
I do, right here.
No, for the lower.
Yeah, right here. There's my outer and my inner.
Oh,
But they cancel. Can you reduce anything?
You can do 2 plus... You can reduce 6.
So these first two pieces look like they might reduce, but the second two pieces don't reduce. And so I would leave it as a single fraction. It's not wrong to write this. Okay? It's not wrong to write this. But just be careful that you don't reduce in some places and ignore it in others. If it doesn't reduce, it doesn't reduce. I would prefer that you leave your answer as a single fraction. And so I would accept this. However, I would also accept this. I just suggest if it doesn't all reduce, you leave it. Yeah.
I just want to confirm. So whenever you're trying to get the roots out of the denominator, you just multiply by the conjugate of the denominator?
Yes, because multiplying by conjugates will always result in a rational number. Now, always, 100% always. If I do this, right, 1 over root 2, I could multiply by minus root 2, but I don't need a negative. I know that in order to get a rational number, because there's no adding and subtracting, there's no FOILing, I just need to pair up that root, and I'm done. Yes. It's just when the expressions get a little more complicated, conjugates is that definition that helps us do that. Okay. Whoop. Absolute value. Here we go. Okay, I'm going to turn my page so I have a whole page to write. Let's see.
Just to be clear, they're bathroom passes.
Yes. Green wristband. Okay. Absolute value. Assume all radicands are... Alright. We have to say something about our positives and negatives here. And there's an assumption for all of Algebra 2, the entire year. All radicands are positive. Radicands, which would be the quantity here. right? Radicands are the quantities here. So we're going to look at some positives and negatives. Circle all quantities that are positive, given x equals -2. Okay? Okay. Circle all quantities that are positive if x equals -2. Okay, so you should have circled here, 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 but I want someone to fill in the blank. Even, yeah, even. Okay, and we're going to go through a series of questions a few times in order to figure out where this absolute value is going to be used. Okay, and let's write x squared is positive. Okay? 2, right? It's a series of questions. X squared is positive. Yes. Okay? Okay? If you square root a positive number, say root 9. So for example, let's just say x is -3, and I'm looking at -3 squared, so that's 9. 9 is positive. Okay? Is the square root of 9 positive? Wait. Okay, I like that you said not necessarily. However, we're not solving. All we're doing is evaluating. When you evaluate, you do not write plus or minus anywhere. Okay? So is the square root of 9 positive? Yeah, it's 3. It's 3. Okay? So the square root of x squared should be positive. Well, it makes sense that you say root x squared is x. But based on our work, the square root of 9 is 3. But if we look up here, x is not circled. X does not have to be positive. So how do I make x positive? You write in your absolute value. Okay? That's where your absolute value comes in.
Wait, why?
We're going to say it again. Red pen. Okay? That's where your absolute value goes. Why did I put absolute value here? Okay. All even powers are positive. The square root of a positive number should be positive. But I didn't circle x. X doesn't have to be positive, guys, but I need it to be. So you're going to have to make it positive by writing in absolute value. Must write in absolute value to make x positive. Okay. 1, to,
Wait, you must write in cell?
you must write in absolute value to make x positive. All right. So we're going to do this. X to the 6th. Same set of questions. We're going to ask ourselves, is it positive? Positive. So it is positive. Should be positive. If you square root a positive number, it should be positive in the answer. Ooh, x cubed. X cubed is not circled. X cubed does not have to be positive. But for our work, if you're square rooting a positive number, your answer better be positive. See this how it wasn't circled? I'm going to need to make it positive by writing in the absolute value.
Wait, so if the numerator, so if the exponent is even, it's just automatically positive.
Almost.
Almost always positive.
Yes.
But
Let's do this one, and that's going to answer your question. Okay, so let's do the 3 questions one more time, and then we'll write the rule after you understand what it is. Let's do x to the 8th.
Wait, what is that?
Should be positive, which is why I put in my absolute value, because x cubed is not necessarily. Okay, x to the 8th is positive.
Wait, is that X?
X to the 8th.
Oh, so wait, the recording is positive.
I got you. There you go. Okay. Square root x to the 8th should be positive.
So it would just be X.
Okay. And last line, well, square root x to the 8th is x to the 4th. Oh.
Wait, so what's the difference between should be positive and
I don't know what this is. Okay. X is an unknown quantity.
okay?
Could be -2, -8, +1, any number we want. We know that x to the 8th is positive because of the even exponent.
Yeah.
Okay? If you square root a positive number, it should be a positive result. I just don't know because x is a variable. I just know that it should be positive. And so the answer is the question.
So if it's negative, it would have an I. So that's the reason why.
But it can't. You're starting with a positive number.
But what if X was like negative?
Yeah, what's negative to the 8th power?
And then okay. So shouldn't it always be positive?
Yes.
So then why
Yeah.
it should be positive?
Should. That's why you want to say should
Oh.
always be. That's fine. You can write the word always. That's okay. That's fine.
Are we gonna do like a practice problem or something?
Yeah, we are. Okay, now let me finish. X to the 4th is positive. Do you need absolute value around x to the 4th? No. You only write it when you need it. Okay? Only write when you need it. It has to do with the results always being positive. And if you can't say always, then you have to write in the absolute value. Okay, so let's do a problem. Okay, yep. Notice that I didn't write absolute value on x to the 4th. It would have been redundant. You don't need it, don't write it. Okay. Let's put up an example and see if you can place the absolute value. Okay. Square root 9 x to the 8th y squared z cubed. Okay, simplify. Then use absolute value after you box the answer. Okay? Absolute value is an after the fact. You can box your answer and scan your whole quiz and place absolute value right before you turn it in. It is not something you have to do before you evaluate. It's something you do after you evaluate. Oh, wait. Forgot my Y. Just Z. Okay. There's my simplified answer. Now I go back and I ask myself the questions.
Wait, would x squared still be in the root?
No.
Because x fourth is 16.
No,
You multiply. Multiply the exponents. Okay, we're going to go one variable at a time. Is x to the 8th positive? Yes. Is x to the 4th positive? Yes. Don't need it. Okay, is y squared positive? Yes. Is y to the 1st positive? Should be. Should be. It's not necessarily, right? You have to say always. Always positive. Okay. Radicand is always positive. That's that sentence. We have to assume the radicand is positive. You can put it around everything, but you don't want it where you don't need it. Because absolute value is really a piecewise definition, and if you don't need it, you don't want it. That's why you don't want to place it everywhere.
So if it's not positive, would we just have to take the
Wait.
negative out and then...
You need to put it around the 3.
No, 3 is already positive. Right? 9 is positive. Is 3 positive? Yes. And so you leave it. 1 second, one question. We're not quite done yet.
Okay.
We're still going. I've only made it to Y. Okay? Question? Okay, so x squared is positive. Is x to the 4th positive? Yes, so I do not need it. Whenever you square root a positive number, the answer should be positive. If it's yes, yes, we're done. Move on. Is y squared positive? Yes. Is y always positive? No. You better put it in because the square root has to be. Okay? So, is z cubed positive? Okay. Your radicand is always positive. Is z cubed going to be positive? Yeah, because my radicand has to start positive. So our first answer is always yes.
Oh, so then it would.
So automatically, z is going to be positive because it had to start positive. Odd powers stay positive. I got you. Hold on. That first assumption we wrote says that the radicands have to be positive. So if z cubed, which means every part of it has to be positive. So is z cubed positive? Yes, that we have to start it yes because everything has to be positive. The only thing that can alternate signs based on a power is an even exponent. Even exponent, odd exponent, even exponent, odd. That's where your signs are going to alternate. But if I have to start positive, so z cubed positive assumes that all other odd powers will also be positive. And so we're going to write the conclusion. And we're going to write it like this. N x to the m equals x to the p. The property written in your notes is not incorrect. It just doesn't fully explain when your powers are different what you're going to do. Okay? And this says if n and m are both even, which is what we looked at, and p is odd, you're going to get the absolute value. It's only even, odd where the absolute value is necessary because that's the only place that the sign could potentially become negative.
So we can't do -3 because has to be positive?
Yeah, square root of 9 is 3.
But couldn't it be negative?
No, not yet. We have to solve. If you say x squared equals 9, can you plug in negative 3 and positive 3? Yes. I'm not plugging in anything. Yes, that's the difference. Okay, n even, m even, p odd. That is the only case
Only case for P
that needs absolute value. That's it. That is the only case that needs your absolute value. The property is written in your notes. It just doesn't quite explain when the powers happen to be different even numbers. Okay, so you want to try one more of absolute value? Yeah? Okay, let's do one more. And I'll leave your property here. Yes. Oh, hold on. I'm going to extend it. You're going to get 4 letters. I guess we have to go like B. Yeah, and my A's look like numbers. Oh, okay. There, that'll do. Yeah.
Wait, so will you get fractions?
Just simplify in radical form. So whatever's left over, leave it in the radical. Right? What goes where? Simplify it, then write in absolute value. Okay, so 2x squared y z cubed b okay, there's your simplified radical. Then you pick up your pencil and you say, okay, do I need absolute value? Even, even, even. No. Is positive, is positive. Is always positive, is always positive. Is always positive. Right? The assumption is all radicands are positive. That is the preface of the whole unit. All radicands will be positive. Okay? Positive. Ooh, not positive. So I'm going to need to make it positive. Positive. Not positive. So I'm going to need to make it positive. Even. Oh. Well, b to the 5th has to be positive anyways, which assumes all odd powers are also positive, and so I don't need it. Notice, even, no, stop using the property. The property does not apply. You need to say even, even, odd in order to use the property. Even, odd, odd. The property does not apply. And so, could I rewrite this slightly more simple? Yes. Where if they're both an absolute value, you could write them together. I'm not going to be picky, right or wrong, as long as you get absolute value around the quantities that need it. It is more important for you to be able to explain to me why you're using absolute value, not just place it correctly. Okay? on a quiz or a test, there will be a big heading that says, please use absolute value for these 2 questions.
Wait, how come you don't need to make
And then the rest of it, you won't be checking it, okay? So I will tell you exactly where you need to use this property so that you're not questioning yourself halfway, okay? And it's like 2 questions.
On the quiz or the test?
2 questions on the quiz, 1 question on the test. But I do ask you to explain it after we finish all the stations. So, Tuesday, something like that? It depends. Question. When we finish learning everything? I think the test is scheduled for approximately the 26th. We'll have to wait and see. When we finish, we will test. Whenever that is.
Are